All right, this is Code Dive. Thank you so much for coming back. We're ready to move on as advertised, and our next point on the agenda is 2 Moon Talks. Now, both will delve into Nokia's involvement in moon exploration. Yes, Nokia will be delivering mobile communication to the moon. The first talk is called LTE's Giant Leap Towards Lunar Connectivity, and it is going to be delivered by 2 seasoned Nokians. Marcin Szczukiewicz has degrees in electronics and telecommunications as well as data science, previously developing and designing networks for telecom providers. He has been a key contributor to many Nokia's divisions for the past 14 years, specializing in software testing for 3G, 4G and 5G radio base stations. His contribution to the unified test environment earned him a recognition as a finalist in the prestigious Nokia Quality Awards. These days, Marcin is exporting his special talents to the moon. Let's welcome Marcin Szczukiewicz. And the second part of this talk will be delivered by Borys, Szefczyk, who combines science with his passion for discovery. He has a PhD in physical and theoretical chemistry. He used to be a researcher at the University of Porto in Portugal and co-authored over 20 papers in computational chemistry. As a long-time passionate programmer, he now works as a Python developer at Nokia, and in a sort of big bang kind of transition, he switched from modeling the tiny universe of particles to the space industry and developing software for a lunar mission. So without further ado, LTE's giant leap towards lunar connectivity. Let's warmly welcome once again Marcin Szczukiewicz and Borys Szefczyk.
Hello. Okay. When we think about the moon and the mission, we often come back to the times of Apollo missions. So let's do it this time as well. At the beginning, the quiz. Do you remember the first sentence transmitted from the moon? Anybody? Louder, louder, please, because I cannot hear. Small step for the man. Yes. Okay. I hear a lot of correct answers. Let's check it. Yes, we can consider 2 basically correct answers. One is Houston, Tranquility Base here. The Eagle has landed. It was just after touching the surface by the lander inside the vehicle. But second, which was heard many times in that room, was that's one small step for a man, one giant leap for mankind. More, of course, famous it was when Armstrong touched lunar surface. So let's hear it again.
It's one small step for man, one giant leap for mankind.
Yes, we could experience the technology from 1960s. It was good enough to transmit such words from the moon to the Earth. It was good enough for the 6 missions, Apollo missions, to be successful. But it's far from current expectations. So from that time, technology did few giant leaps. So can you imagine a world without mobile connectivity? Difficult. So why not to have it on the moon? Now, Borys.
Okay, let me first tell you what this talk is going to be about. We are at the beginning of a new space era. Every year, more and more space missions are launched, and we at Nokia want to be a part of it. Actually, we will be a part of it because soon, next year, we will send and deploy the first ever mobile 4G LTE network on the moon. And it isn't just Nokia and our partners. The whole commercial space industry is growing. What does it mean? It means that pretty soon, maybe many of you could be part of it. Sounds great? I think it does. So, the new space era. Let's see where we are now. The chart that I'm showing here illustrates the number of lunar launches, just lunar launches, per decade. You can see a huge number somewhere in the 60s, 70s, during the time of the Apollo program, when there was a race between the United States and Soviet Union. Then the number has declined and it's growing again. Only in the last 12 months, there were 4 attempts to land on the moon, although only one was successful. The Indian Chandrayaan-3 has landed successfully on the moon. One more is on the way. But it doesn't end there. The plans are much more ambitious. I'm sure you heard about the Artemis program. The goal of this program is to send humans to the moon again, but not just that. The plan is to build a permanent base camp on the moon. And obviously for that, we need good communication technology. And as I said, it's not just few companies. The situation nowadays is much different from the first space era, when everything was in the hands of state agencies. Nowadays, there are more private companies involved. Of course, you know SpaceX, but there are many more. Here I'm mentioning just the 2 of them, which happen to be our partners, Intuitive Machines and Lunar Outpost. But the gist of it is that the whole space industry is growing. For us at Nokia, it started with the Tipping Point program, which is led by the Space Technology Mission Directorate of NASA. The goal of this program is to offset the development of technologies with potential space applications from the state agencies to the private sector. The aim is to develop these technologies and ultimately to apply them in the future missions. In 2020, Nokia proposed to build and deploy the first 4G LTE network in the space, based on terrestrial technology which we already use here on Earth. This communication system should provide better speeds, better reliability, and should offer communication at greater distances than the currently used technologies. And the currently used technologies are basically VHF and UHF, which we know, for example, from radios like this one. In the same year, in 2020, our partner, Intuitive Machines, received a grant to develop a small hopper vehicle able to carry a small 1 kilogram payload, which could jump from place to place propelled by rocket engines and enter the interior of craters and investigate what's in it. Why there is so much interest in the craters? Because there is a research interest to find ice on the moon, and because there is nearly no atmosphere on the moon, the only places, due to the temperatures, the only places where we could potentially find ice are the areas which are in a permanent shadow, like like the craters. Now, about the mission itself. The mission is called Intuitive Machines 2, and as you might have guessed, it's a second mission of the company. The first one, called Intuitive Machines 1, will launch early next year. IM2 will follow. Within this mission, the Nova C lander will be taken into space by the SpaceX Falcon 9 rocket. The plan is to land on the Shackleton Ridge. The Shackleton Ridge is an elevated region that connects the Shackleton crater, which you can see in the center of this picture, with Gerlach crater, which is in the back. What are the components of this mission? There is the lander called Nova C, which I have mentioned already. The lander will carry all the payloads, including the Micronova hopper, the Lunar Outpost map rover, our communication equipment, and some other equipment that will be used for other experiments that will be conducted during this mission. The communication equipment consists of the BTS, which will be installed on the lander, antennas that will be mounted on top of the lander, and the user equipment, the phones, that will be installed on the vehicles, the hopper and the rover, together with antennas, obviously. These three elements will form a basic mobile network. Besides our experiments, communication experiments, there will be also an interesting experiment going on, which is called Prime 1. The goal of this experiment is to detect traces of ice in the lunar regolith. During that experiment, the drill that is installed on the lander will dig into the ground, excavate it to the surface, and the mass spectrometer will detect volatile particles that are released from the soil, looking for traces of ice. And now, let me pass over to Marcin, who's going to talk about the connectivity.
Okay, welcome again. All right, now I will reveal some more details about the target for our project, so lunar connectivity. Let's come back to that NASA tipping points selection announcement and focus on the first sentence. There are three important things I want to explain later. Terrestrial technology, first LTE 4G in space, and also deployment of communication system in space. Let's start from terrestrial LTE technology. LTE standard was proposed in 2004 and became commercial around 2009. Devices are designed for indoor-outdoor use for urban and rural areas. Its coverage now is estimated for the about 90% of the human population. To imagine the scale, let's compare that only 75% of human population has access to safely managed drinkable water. So it's huge coverage. But how LTE is built? Let's start from terminals, which we keep in the pockets, like smartphones, but those are not only terminals. It can be IoT devices, mobile hotspots, routers. So those are terminals in terminology of LTE called user equipment, for short UEs. I will use that name later. So Next, those terminals are connected to base stations, and base stations also can be different size, and we can notice them by observing our landscape. And when we see antennas, always close to that antenna is a base station. I have one example. This is a base station of small size, designed for outdoors, so it can be mounted on outside of the buildings. Those base stations from other side are connected to the core network, in terminology of LTE called Evolved Packet Core, for short EPC. Typically, this is a large data center with multiple devices, because it is serving large areas of countries with millions of users. And that core network is connected also to outside world, most interested for us, internet content. So this is basically how terrestrial LTE is built. But how we want to demonstrate it on the moon? We want to use off-the-shelf technology. It means that we want to use equipment as it is on the Earth, and modify it only a little to survive, of course, the launch, landing, and travel through the space, but also optimize a little for the conditions of the lunar environment, which is completely different, like ours. To have a network on the moon is enough to have 2 terminals, eNode B and EPC. The tricky part in our project is eNode B, because like I mentioned a few minutes ago, that core on the Earth is large data center. But on the moon, we don't want to charge vehicles for the data used or limit for them gigabytes. So we don't need to care about the roaming to another network, because we will be only one. So having only all necessary functions, we can manage them as a software and use the same equipment as eNode B. So only one hardware with 2 functions. Let's have a look how it will be installed. That eNode B with integrated EPC is installed on Nova Sea Lander. This is a device about 4 meters high, and base station is mounted on the top. You can see that gray box. UEs, so terminals, are mounted on the vehicles. So one for hopper, one for rover. All devices are equipped with antennas. Like you see, LTE is on the moon, but we need to have also operations on Earth. So there is also second actor needed. We need operation and maintenance software, which was developed for each of the vehicles, which allows interoperability between our LTE devices and partner systems. And also we need a second part on Earth to be integrated with Mission Control Center. Those 2 sectors are connected with direct-to-Earth link. Such complete communication system allows us to meet the mission goals. So we can autonomously deploy, configure, manage devices just after landing and during the mission. We can send commands, so manage equipment, but also trigger experiments by sending telecommands from mission control to all devices. We can monitor telemetry and collect scientific data by receiving it from the moon and collecting on the Earth. We can also visualize everything and also provide user interface for operations personnel. Okay, so now let's focus on this second sentence. There are two things which I want to explain. One, greater distances, increased speeds, and also more than current standards. So let's start. What are the current standards? Most missions touching the lunar surface are just lander and orbiter, and sometimes lander, orbiter, and rover, which is requiring wireless communication on the lunar surface. Let's have a look at the picture when this is from Apollo era. This and last man on the moon was present in 1972, December, so soon it will be 51 years from that time. Please have a look. Please have a closer look at that picture. Simply, there is a communication, voice and data communication between astronauts and equipment, and it is done using VHF technology. VHF is a band of the spectrum, and that technology is then and now still used in marine applications. So maybe we have any sailor in the room. Is there any sailor? Yeah, probably I see. Sorry, I cannot see very well because I have lights blinding me. So if there is any sailor, on every boat there is a VHF equipment to communicate between boats or from both the ports. And so very often such devices as such walkie-talkie. But also it can be used for the data. Of course, technology did some jumps, and we required more bigger data rates. So later, technology started to use UHF frequency bands, and the advantages, for example, of course, the high data rates, but also they can better handle obstacles like walls on the Earth. What to mention that also Wi-Fi is operating in the UHF band as well as LTE and further technologies partially are also using UHF band. Okay, Intuitive Machine 2 mission, of course, want to prove that LTE meets its expectations in lunar environment. So, of course, the first and most important for us is to survive, to be self-deployed there and starting to be operational. But later we want to check more closely parameters of the network. So few experiments are planned, short-range communication and collecting parameters in such conditions, long-range, so more than 2 kilometers, and also check parameters in such conditions. Please notice that on the moon, everywhere, the range is limited by horizon, but on the moon, horizon is much closer than on the Earth, simply because moon is 4 times smaller than Earth. But also because the antennas on the lander, on the vehicle rover are relatively low, also obstacles in between transmitter and receiver may limit range, but also capability of the rover to omit all those obstacles and be as far as expected. Very interesting experiment also will be to check uninterrupted connectivity with conditions when of non-line of sight. So there is no direct visibility between transmitter and receiver. It may happen when micronova hopper will descend into the crater, searching for that lunar deposits, and taking the picture of them, and then it maybe will be we'll have possibility to have the first pictures of the ice on the moon transmitted over LTE network. Of course, there is a much more challenges which we are facing. More of them also will be explained in next presentation by our colleagues. So, our mission and our demonstration of LTE on the moon is just first step for permanent lunar mobile networks. So there is no other mobile network better prepared for such expectations. So experiencing mobile networks on the Earth, we can easily imagine the future when the people are communicating on the lunar surface, the habitats have a coverage. Also, we can remotely monitor and also control mining machines, construction machines, robots, etc. So that vision simply will come true because we are living in a new space era. So communication networks and mobile telecommunications are important part of economy on Earth. It will not be different on the moon. So communication is a key. Terrestrial technologies can be used in space and will be used in space because there is no sense to create everything from scratch if we have best, well-checked technologies which are proven here. And space industry is growing. Yeah, it was shown that we have big interest in the new space era of private companies. So probably soon most of us will work closer to space projects than now. So yeah, welcome in space industry. Okay, because we are in the cinema, there is a great opportunity to watch movies. So I will stop talking for a while, and we have a nice movie to show. I also like to see it in such conditions. So let's enjoy. Can we have such movie presented? Okay, now questions and answers. At least questions.
I think first, a round of applause, please. Marcin and Borys. Thank you so much. Yes, make yourself known, make yourself visible. If you've got a question, I thought I saw one over there, please. Thank you.
Thank you. I would like to ask, because as we probably all know, no software is perfect right from the start. Do you foresee a way to remotely update the Node B software that will be present on the Lunar lander?
Of course, there is a lot of recovery procedures prepared. So we are aware, of course, of such situations, but also we want to prepare software as good as possible to not to have such situations. Please notice that there is a big limitation which is not on the Earth, that direct to Earth link, which has not huge capacity as fiber networks on the Earth. So also we cannot, let's say, have unlimited access to the moon. So rather we are focusing on preparing and testing such software to not to have such situations than to rely on the recovery procedures from the Earth. But yes, we are aware.
Okay, I would also like to ask, as we probably all know, one of the Nokia's main products is not only a LTE network, but also a 5G network. If the mission with deploying LTE on the lunar surface succeeds, do you foresee an attempt with 5G network, or the increased throughput and possible limitations of range are not worth the trouble of trying the 5G network for now on lunar surface?
Yeah, I would say that as you have seen in the slides, 5G is also considered as a technology that could be used in the space missions. In this mission, we are deploying the well-known and well-tested 4G technology, and mainly because of that, it's been chosen for this mission. But yes, it's the future.
Yeah, please notice that the tipping points was announced in 2020. So it was when 5G was not mature enough to be considered for such important mission. And natural consequence, if we succeed, we hope, will be the next generation.
Thank you. Any more questions, insights, please? One over there. Could we have that one over there? Just the middle of the room. Yeah, microphone, anyone? Over there.
Raz.
Okay, we've got one over there then. Thank you.
So could I ask, yeah? So actually, here, I'm on the other side. Okay, never mind.
Sorry, I'm blinded, so
we can see.
No problem.
Okay.
I have two questions. First is about this direct link. Is it the regular space communication, and you just encapsulate the packages on the space link? That's the first question. And the second about hardware. I believe that you designed hardware from the scratch, because we have different conditions like radiation, temperature, vibration, and so on. So is it new hardware which you designed for that mission?
before I answer, I want to encourage you to join next session. There will be a lot of about such. It will answer all your questions. So
And many more.
maybe let's do it this way, because I don't want to steal the show Still the show of my colleagues.
More questions here. We've got two here and then one over there, please.
Hi, what is the most challenging and risky part of your mission from your point of view?
Oh, there's so many parts which may not work. Yeah, this is first experience for us. So, but from the launch through the travel through the space to landing to self-deployment conditions, so everything is risky. It's difficult to select what is the most. Maybe you have an idea.
No, it's true. There are so many factors: the environment, the radiation, the travel, the shock, the fact that it's uncrewed mission. So whatever we send there must work there. Although we have the communication, that's why it's so important. As long as we have the communication, we can still control what's happening there.
Yeah, but in our project team, we often think what may happen and try to predict some scenarios, very strange even, and try to be prepared for them.
Yes, that's also one of the challenges to foresee what could happen and being prepared for that, having procedures in place.
Second question from my side. What part of the LTE system required biggest changes, modification to succeed in that project? Was it O&M or the U-plane or C-plane?
Maybe once again I will try to propose to join the next session. Some answers also will be there. But answering, the goal was not to change, and only change as a little that is required. So we want to keep terrestrial technology. Yes, so it was the goal also for the mission to demonstrate technology from Earth on the Moon. But of course, there are different conditions we had to be prepared, and colleagues will tell about it.
Hi, quick question. Could you share which Nokia locations are participating in this project?
No.
Thank you.
Short answers, short questions, one more, please.
United States for sure.
I have one more question. I would like to ask, because as you mentioned, the conditions in space are harsh, especially the radiation. I would like to ask, do you foresee some radiation-proof mechanisms in the software itself, or will it be limited to hardware, like hardware-proofing the equipment and maybe running several instances of the eNodeB software?
So once again, please join next session. Yeah, we were showing mostly that overview of the mission, and such interesting details will be followed. So I don't want to be rude, but...
Look, these are very, very smart people, not only in designing LTE on the Moon, but also how they run their talks. So this was just the taster, and they knew perfectly well what kind of questions you're going to ask, and they said, okay, after this, the set of questions will be answered in Moon Talk number 2, which will be delivered to you right after this break. So enjoy your break. Do come back for more Lunar stuff, and we will, before that, thank Marcin and Borys.
Yes.
Thank you.
Thank you.
Thank you.